Good day to each and everyone. The Group 1 is pleased to present today's report on the topic of statistical measures of data. As we know, statistics is a vital branch of mathematics that provides the necessary tools and techniques for efficient data collection, presentation, analysis, and interpretation. The study of statistics circulates around the study of the data sets. And there are two important types of data sets, namely the population and sample. Population refers to the totality of observations of which a study is concerned, and any part or portion of the population is called a sample. In simpler terms, population refers to the entire group being studied, while sample refers to a smaller subset of the population being studied. Here, let's talk about the importance of data collection in statistical analysis. Collecting data is one of the most critical stages in a statistical analysis, and it is essential to do it in a way that ensures the accuracy and relevance of the results. Data can be collected in a variety of ways, each with its own advantages and disadvantages. Many researchers use samples to collect data and information about a particular variable from a large population. This process is less expensive and less time-consuming compared to conducting a census, and in some cases enables the researchers to get more detailed information about a particular subject. However, it is important to note that obtaining a sample may lead to wrong conclusions regarding the population. Hence, it is crucial that the sample selected is a good representation of the population. This means that the sample should accurately reflect the characteristics of the population, and that the selection process should be random and unbiased. If the sample is not representative, the results may be inaccurate, and any conclusions drawn from the analysis may not be applicable to the population as a whole. So, under parameters and statistics, the statistical measure or characteristic obtained by using all the data values from a given population is called a parameter, while the statistical measure or characteristic obtained by using data values from a sample is called a statistic. Parameters provide information about the entire population, while statistics provide information about the sample being studied. So, after the data collection, the researcher must organize the gathered data in a meaningful way to describe situations, draw conclusions, or make inferences. This can be done using various techniques such as graphs, charts, and tables. Organizing data in this way enables researchers to see patterns, trends, and relationships between variables and to make informed decisions based on the analysis. So, in research or survey, data is collected, and to describe it meaningfully, one needs to summarize the data. One of the basic statistical concepts involves finding measures of central location of a set of numerical data. So, there are four common measures of central location, namely mean, median, mode, and weighted mean. So, as we go forth, we will know the definition and we'll give you more examples of these common measures of central location. Number one is the arithmetic mean. The mean is calculated by summing up all the data values and dividing the result by the total number of the data points. Given a collection of n data points, x sub 1, x sub 2, x sub 3, and so forth. The formula for computing the mean is given below. For a sample, the mean is denoted by x and is calculated using the same formula as the population mean. The only difference is that the simple mean is computed using a subset of the population data. So the formula for calculating the sample mean is given below, where n represents the total number of values in the sample. So on the other hand, for a population, the mean is denoted by the lowercase Greek letter read as mu, and the parameter is given as below, and represents the total number of values in a population. So let's try this example number 1. In a recent quiz for MMW course, 5 students out of 20 got the test scores of 41, 39, 50, 47, and 44. To determine the average performance of these 5 students, we will calculate the arithmetic mean. The formula for calculating the mean for a sample is to add up all the values and divide the sum by the number of values in the sample. Therefore, to calculate the mean for the 5 students, we add up their score. So 41 plus 39 plus 50 plus 47 plus 44 is equal to 221. Then we divide the sum by the number of students by 5. So 221 divided by 5 is equal to 44.2. Thus, we can conclude that the mean test score of the 5 students in the MMW quiz is 44.2, or we can also say that the average test score of the 5 students in the MMW quiz is 44.2. And for this, to calculate the mean using Excel, we will use the average function. The formula for the average function is equals, then average, the word average is in capitalized, then after this is a open and close parenthesis, number 1, comma, number 2, comma, and so forth. So we will enter the data values in cells A1 to A5, or it depends on you. So then use the average function to calculate the mean. The Excel formula to calculate the mean for this set of data would be equals average A1 colon A5. So after entering this formula, Excel will automatically calculate the mean of the data set and display the result in the cell where the formula is entered. So in this case, the mean test score of 5 students is 44.2, which is the same value we obtained in the previous example using the formula for the arithmetic mean. Therefore, we can conclude that the Excel function average can be used to easily and quickly calculate the mean for a set of data.
So, ito yung formula, measures of central location, measures of average. So, ang formula dito is yung sa taas. And papalitan mo lang yung mga x dyan. Papalitan mo lang dyan is yung given na numbers. For example, 18 plus 20 plus 17 plus 17 plus 18 plus 19 plus 19 plus 20 divided by 8. And then, i-add mo lang siya, and ang answer is 148 divide 8 is equals to, i-divide mo lang din siya, 18.5. So, hence, the average age of the working students in the 2 sections of MMW class is 18.5. Kasi yun yung tanong. The ages of working students in 2 sections of MMW class are 18, 20, 17, 17, 18, 19, 19, and 20. And you just have to find the mean.
So another example using Excel to calculate the mean, just use the formula for average function and plot the numbers, and then automatically will give the answer.
So there are properties of the mean. First, it is unique, meaning it has only one value. It can be computed by numerical data only, that is interval or ratio level of data. It is easily affected by extreme values of the data. Thus, one should be cautious in using the mean when there are extreme observation or outliers. If the outliers is extremely low, it pulls down the value of the mean. If the outlier is a very big value, it magnifies the mean. If the mean is greatly affected, then our summary description of the data is distorted.
Let us move on to the median. So the median, when the data are arranged in increasing or decreasing order, the median is the middle number or the mean of the 2 middle number in a data set. Meaning that the median is the data point which divides the distribution into 2 equal parts. So we have steps in computing the median from a set of data. First, arrange the data either in increasing or decreasing order of the magnitude. Then select the middle point. So in finding the median of a data set, we have case number 1. When the number of observations is odd, there is only one middle value, and this is the median. The position of this data is located at the n plus 1 divided by 2 data point, and this is denoted by x for a sample and n for population. Finding the parameter, we have the formula n is equals to x to n plus 1 divided by 2. And using statistic, finding the sample, we have the formula x is equals to x to n plus 1 divided by 2. And the case number 2, when the number of observations is even, there are two middle values. The median is the mean or average of the two middle values. The position of the two data points are at n divided by 2 and n divided by 2 plus 1. Finding the parameter or the population, we have the formula n is equals to x to n divided by 2 plus x to n divided by 2 plus 1, and then we have the denominator divided by 2, and finding the statistic, using the statistic, finding the sample, we have the formula x is equals to x to n divided by 2 plus x to n divided by 2 plus 1 and divide by 2. Example number 1, the efficiency ratings of 7 employees of a certain company are 81, 69, 93, 76, 87, 70, and 95. Let's find the median. In step 1, arrange the data in order. So as we can see, we have arranged the data in an increasing order from 69, 70, 76, 81, 87, 93 up to 95. Step 2, select the middle value. Using the parameter, finding the population, we have the formula n is equals to x to n plus 1 divided by 2 is equals to, we have x, the number of the set of data, we have 7, and then plus 1 divided by 2 is equals to x, we have 7 plus 1 is equals to 8, and then divided by 2 and equals to x, we have 8 divided by 2, we have 4, x to 4, and then we have 81. Therefore, the median efficiency rating is 81. Example number 2, the weights in kilogram of a sample of 6 female Miss Universe candidates are 50, 49, 53, 58, 48, and 55. Find the median. Step 1, arrange the data in order. So as you can see, we have arranged the data in a decreasing order from 58 down to 55, 53, 50, 49, and 48. Step 2, select the middle value. Using a statistic, finding the sample, we have the formula x is equals to x to n divided by 2 plus x to n divided by 2 plus 1 and divided by 2. We have x, the number of set of data, we have 6, and then divided by 2, plus x, the number of set of data, we have 6 divided by 2, and then plus 1 and divided by 2 is equals to x, we have 6 divided by 2 is equals to 3, plus x, 6 divided by 2, we have 3, and then plus 1 and divided by 2 is equals to, we have x 3 plus 3 plus 1 is equals to 4, we have x to 4, and then divided by 2 is equals to 53 plus 50, and divided by 2 we have 51.5. So thus the median weights in kilogram is 51.5. So using Excel to find the median. The Excel function median can be used to calculate the median for a set of data. We have here example number 1, illustration for case 1. The number of observations is odd. So open a new Microsoft Excel spreadsheet by double-clicking the Excel icon. Click on cell A1 and enter the formula without quotations. We have here the we have here the formula, the equivalent sign, median, and then open parenthesis, and type and or enter the number of data, the set of data, and press enter, and the median of your set of data will appear on the cell. So we have here the example, the equivalent sign, median, open parenthesis, and our set of data. We have 81, 69, 93, 76, 87, 70, and 95, and we have pressed enter, and we have 81 as the median of the set of data. We have the example number 2, illustration for case 2, or the number of observations is even. By typing the formula, we have the equivalent sign, median, open parenthesis, and our set of data. We have 50, 49, 53, 58, 48, and 55. And after pressing enter, we have the 51.5 as the median of the set of data. So we have the properties of median. The properties of median is that it is unique for numerical data. It can be computed for ordinal, interval, or ratio level data. It is not affected by extreme values, since the median uses only the middle values or value.
Number 3, the mode is the value in the dataset that occurs most often. It means that the mode is the data point with the highest frequency. Note, a dataset can have more than one mode or no mode at all. Example, find the modes of the following sets of row data. In letter A, the numbers are 1, 9, 2, 8, 3, 7, 5, 9, and 6. And here in our solution in letter A, the mode is number 9, since it has the highest frequency, which is 2. And in letter B, our numbers are 8, 2, 9, 1, 5, 7, 6, 3, and 4. And our solution, each number occurs only once. Since no number occurs most often than the others, there is no mode. And in our letter C, the numbers are 9, 2, 1, 9, 3, 5, 7, 1, and 6. And in our solution in letter C, the mode are 9 and 1, each with a frequency of 2. And if the mode has a 2, it's called bimodal. And if it's more than 2, it is called multimodal. Since a dataset has the 2 modes, it is called bimodal. Using Excel to find the mode. The Excel function mode single can be used to find a single mode for a set of data, but very careful. If there is more than one mode, Excel yields only the first mode. If there is no mode, Excel displays an A. If the data have more than one mode, the mode multifunction can be used. This formula A must be correctly entered as an array formula using the procedure below. Be careful, if the formula is not correctly entered as an array formula, it will yield only to the first mode, which is the same result from using the mode single function. Select a range of empty cells in a single column adjacent to the data, in which the multiple mode results will be displayed. Select these cells by clicking the top empty cell in the range, and while holding down the mouse button, dragging the cursor to the bottom empty cell in the range. If you don't know how many modes the dataset has, select 5 or more empty cells to display the results. With the empty cells still selected, enter the mode multi formula in the function bar. After entering the formula, press Ctrl plus Shift plus Enter to display the results in the range of empty cells selected in step 1. If more cells were selected in step 1, then there are modes and A will be displayed in the extra cells. Here is our example, number 1, and then the number 2, and then the number 3. Properties of the mode can be computed for any type of data, whether it is nominal, ordinal, interval, or ratio level data. It may not be unique since sometimes we cannot just get one value like on the example number 2 shown above, and it may not exist like on the example number 3 that is shown here.
The weighted mean. Sometimes one must find the mean of a data set in which not all values have the same degree of importance. Just like a data containing scores of a student in the quizzes, exam, and assignments of particular
McCoy
subjects,
wants to commute
scores
his
in
grade
major
points
exams
average
way more
GPA.
than those in
He
quizzes.
got the following
This
grades
type
in
of
his
measurement
subject
in
last
which
semester.
we often use when some data
Solution
values are
using the
more
given
important
formula
than
for the
others
weighted mean.
is called the weighted mean,
Hence, McCoy's
which
grade
is
point average
denoted as
GPA is
WX. We find
1.767.
weighted mean of a variable x by multiplying each value by its corresponding weight and dividing the sum of the products by the sum of the weights.
Example: McCoy wants to commute his grade points average GPA. He got the following grades in his subject last semester. Solution using the given formula for the weighted mean. Hence, McCoy's grade point average GPA is 1.767. Using Excel to find the weighted mean. Although Excel doesn't have a weighted mean average function, it does have a function that does most of the work for you. Sum product. Examples: S1 and S2. Exercises for number 1 and 2. Find A mean, B median, and C mode. The time spent in minutes each student in working the assigned problems are provided below: 22, 25, 19, 33, 31, 22, 42, 25, 17. The prelim scores of MMW students are given below: 79, 80, 49, 67, 86, 91, 36, 33, 77, and 50. Suppose a student made an average score of 65% in the attendance, 60% in quizzes, and 45% in the first prelim, 48% in second prelim, and 54% in the final exam. What is the final average score of the student if the attendance weighs 5% of the total grade, quizzes 25%, first prelim 20%, second prelim 20%, and the final exam weight 30%? Did the student pass the course if the passing cutoff score is 60%? For number 4, 5, use Excel. Given below the final scores of 50 MMW students, find the A mean and the B median and C mode. Customers' feedback in a certain mobile product is given below: very unsatisfied, unsatisfied, satisfied, very satisfied. Assuming very unsatisfied 1 grade point, unsatisfied is equals to 2 grade points, satisfied equals to 3 grade points, and very satisfied is equal to 4 grade points. Find the weighted average.
Thank you everyone for your attention during this presentation. If you have any further questions or would like to discuss any aspects of the report further, please feel free to let us know. And Mom Cali, we appreciate the opportunity to share our findings with the group.